Today we're going to do lesson 6 in our workbooks. This is page 99, and we're continuing on with rational exponents, so fraction exponents. Before we get there, let's start with review. So our product law, when we're multiplying two powers with the same base, I can add the exponents. Power of a power, so when there's that lovely bracket in between, we can multiply. Power of a quotient, you won't use a lot, but you can distribute that exponent to both terms in your numerator and your denominator. Integral exponents, this is where we can then move it to make sure our exponent is positive, so in this example we'll move it to be in our denominator. Rational exponents, this is where our numerator is the exponent and the denominator is our root, so we get the nth root of x to the power of m, or the nth root of x, that answer, to the power of m. Doesn't matter. Quotient law. We subtract. Power of a power, you multiply it in. Okay, so let's go through a couple of these ones below. X to the power of 1/6. The 6th is our root, so we get the 6th root of x. On this next one, really tricky with that negative. So remember, it's like that negative is hanging out front, and then we have y to the power of 5/4, which then gives us negative the 4th root of y to the power of 5. So it's like you would do your radical operation, or this portion of it, and then multiplying that negative. Next question, slightly different because of those brackets. So I get the cubic root of negative z all to the power of 5. Now remember, you can write your answers like that, or I could do the cubic root of negative z to the power of 5. If you do it the second option, remember that that negative z would be in brackets. Because it's a 5, it doesn't matter, but it's just a good habit to be in. D, this one's a little bit trickier. So I have a negative here. So let's first deal with that. So really this is saying 1 over negative z to the power of 5/3, which then gives us 1 over the cubic root of negative z to the power of 5. This next question is a little deceiving. Now only the 3/4 exponent is only to that t. So this is saying 5 times the 4th root of t to the power of 3. Versus on the last question, it's that whole thing. So I get the 4th root of 5t all to the power of 3. So you could write this one like that, or I just want to show you it would be 5t all cubed. Up to you which way you want to go. Okay, class example 2. So write each expression as a power with positive exponents and then as an entire radical. So this is basically saying show your steps. So my first step would be to combine these. So we're looking at fraction operations again. So I have 3/2 times x. I could say this is 1/1. Not helpful because I want that denominator of 2. I want that common denominator. So let's write it as 2/2. Well, now I can add my fractions. 3 plus 2 is 5. We don't add our denominators. So this first step, x to the power of 5/2, is a power with positive exponents. Now as a radical, that's the square root of x to the power of 5. Now remember, if this number is a 2, our index is a 2. You don't have to write that. I could just write the root of x to the power of 5. Both are equally correct. Okay, next question. I can subtract these 2. I'm going to end up with a negative. That's okay. 1 minus 5 gives me -4. So I get y to the power of -4/3. So I'm going to move that to the denominator. So 1 over 4/3, which then becomes 1 over the cubic root of y to the power of 4. This next question, multiplying fractions. So we multiply straight across. So I'm going to get a 1 times 2 is 2. 2 times 3 is 6. Always reduce your fraction, so this becomes 1/3, which is then just the cubic root of a. This next one, again, lots of different ways you can go through this one to solve it. I'm going to go first and do my multiplication of this. 2 times negative a half is going to become x to the power of 1 over y to the power of negative a half. Remember, there's like this hidden 1 here. So now because of this, sorry, this is going to be negative 1. 2 times negative a half is negative 1. So now I'm going to flip both of those so to get rid of those negatives. So I get y to the power of a half over x, which then gives me the square root of y over x for your final answer. Okay, let's do these next ones. It's the same idea, slightly more difficult. So on this next question, remember I can multiply my bases. 4 times 3, or my coefficients, 4 times 3 is 12. I'm going to multiply, because I'm multiplying, I add those exponents. I'm going to write this one out for you. So I'm going to get 3 over 4 plus, I have to convert this to be a 4, so that's going to be 2 over 4. So plus negative 2 over 4. So I get 12x, 3 minus 2 gives me 1/4. Remember, it's only x to that power, so I get 12 times the 4th root of x for your final answer. This next question is a bit of a doozy. I would start off by, let's do my fractions. So 5 over 25 reduces to 1/5. X 3/5, that's going to just stay there. This is a negative 3/5, so that's going to move up. So now I can say 3/5 plus 3/5 is equal to 6/5. So I have x to the power of 6 over 5 all over 5. So then that is the 5th root of x to the power of 6 all over 5. C. What's tricky about C is you have to remember is this 4/3 applies to the 8. So this is going to become 8 to the power of 4 over 3 times a to the power of half times 4 over 3. So then this first term, I'm going to get the cubic root of 8, that answer to the power of 4 times a 4 over 6. The cubic root of 8 is 2. 2 to the power of 4 is 16. Times a, I'm going to reduce that to the power of 2/3. So I get 16 times the cubic root of a squared. So these questions can be tricky because there's a lot of steps. We're combining fraction operations, we're combining integers. There's lots of room for error. So you just got to work slowly and make sure you're remembering everything you know. So we're using these rules. They've just rewritten this for us. Now we're going to go in the other direction. So write a radical in as a power. So we're working backwards. So remember, my root is the denominator, my exponent is the numerator. So this first one's going to become a to the power of 5/3. Next one, a to the power of 2/5. No number, it's like there's a hidden 2, so a to the power of 9 over 2. This last one's a little bit trickier, so let's start off by rewriting this as 1 over a to the power of 7 over 2, because that hidden 2. You also could write this one then as a to the power of negative 7 over 2. This answer is actually better, because we always want to leave our answers with a positive exponent. Okay, write the following and evaluate. If we were doing this exam traditionally, I would never give you large numbers. So I would never give you this 1296. I don't expect you to know that without the use of a calculator. The next two you should be able to do without the use of a calculator. So write as a power, then evaluate. So first off, the square root of 169, I hope we all know is 13, but they wanted to write as a power first off, so this is 169 to the power of a half, which is then 1 over 13. This next one, there's a couple steps. So we always want to work inside out. So this is saying the square root of 64 is really 64 to the power of a half. That answer, I'm taking a cube root of it. So I have 64 to the power of a half, all of that to the power of a third, which gives us 64 to the power of 1 over 6. I don't expect you to know this answer, but it is 2. Okay, so our last example here, I want you actually to pause the video and try these on your own. I'm going to go through them and write out all the solutions, but I want you to pause it, stop, try all of them, and then check your answers as you go. So here are all my final answers. Again, we're going to give you nice numbers because normally we expect you to not use a calculator. I'm going to go through how to use your calculator on a few of these. Some of these, like question C, A, B, and C with the coefficient and variables, it's a little bit trickier to remember that you can separate the two, and that's because we'll get more into that in our next unit. But you're still very capable of doing that. I just want to show you how to do different roots on your calculator. So if you take out your calculator right now, say I wanted to do the 5th root of 32, you're going to put your root in first, and then you can go to math, and then down to number 5, where it has the x root. And then it automatically puts the 5 to be your index, and then you can type in 32, enter. So again, if I want to do the 6th root of 64, like that one question, I can go 6, math, down to 5, put in my number, enter. So again, remember, that means I'm multiplying 2 6 times. So 2 times 2 times 2 times 2 times 2 times 2 brings me back to that 64. So that's our final lesson for this concept. So these are the questions I would like you to do. I've leveled them for difficulty for you. One thing to note, numbers 3, 4, 5, and 7, pick 4 from each of them. I know there's a lot of questions here, so we're going to give you lots of class time to do this. Make sure you're managing your class time. So this video is about 13 minutes long, so you have 45 minutes then to be working on these questions. As always, email me if you have any questions on them. I can make a Zoom video or supplementary recorded videos as needed. Have a great day.